when dealing with a 120/208 volts panel being fed from a meter stack that's supplied by a 400 amps breaker where the ground and neutral are bonded, it's important to understand your grounding options. You have two main choices. Firstly, you can run a 4-wire circuit with a separate ground rod. Secondly, you can use a 3-wire circuit and bond the neutral and ground also to a ground rod. Let's delve into both these options to understand the best approach. The first option is to use a 4-wire circuit with separate hot, neutral, ground, and equipment grounding conductors. In this setup, you would install a new ground rod at the panel location and connect the equipment grounding conductor to it. Crucially, you leave the existing ground and neutral bonded at the meter stack. This approach provides the highest level of grounding protection. It complies with current electrical codes. The advantages of using a 4-wire circuit with a separate ground rod are significant. Firstly, it offers the best possible grounding protection. Secondly, it ensures compliance with modern electrical codes. Now let's consider the second option, which involves using a 3-wire circuit and bonding the neutral and ground. In this case, you run a 3-wire circuit with hot, neutral, and ground conductors. You bond the neutral and ground conductors together at the panel and install a ground rod at the panel location, connecting the equipment grounding conductor to it. This method can be simpler and less expensive to install. It might be permitted in certain jurisdictions. The advantages of the 3-wire circuit with a bonded neutral and ground are: firstly, it is simpler and potentially less expensive to install. Secondly, it might be allowed depending on local regulations. However, it's important to note that the recommended approach is generally the first option, the 4-wire circuit with a separate ground rod. This provides superior grounding protection and aligns more closely with current electrical codes. Before making any decisions, always consult your local electrical codes and regulations. Have the installation inspected by a qualified electrician to ensure it meets all safety standards. If the panel is located indoors, the equipment grounding conductor should be run through a grounded conduit. This adds an extra layer of safety and protection. Now let's consider the specific components of each approach in more detail. In the 4-wire system, you need to ensure that each conductor is appropriately sized for the load. The hot conductors, carrying the 120/208 volts power, must be rated to handle the expected amperage. The neutral conductor should also be sized appropriately, considering any potential unbalanced loads. The equipment grounding conductor plays a crucial role in providing a low impedance path for fault currents back to the source. This helps to quickly trip the breaker in the event of a ground fault, minimizing the risk of electrical shock. The ground rod itself should be installed according to local codes, typically driven at least 8 feet into the ground. The connection between the equipment grounding conductor and the ground rod must be secure and corrosion resistant. In the 3-wire system, the same considerations apply to the hot and neutral conductors. However, the bonding of the neutral and ground at the panel is a critical aspect. This bond creates a single point where the neutral and ground are connected, ensuring a common reference point for voltage. Again, the ground rod is essential for providing a path to earth in case of a fault. When evaluating which option to choose, consider the age of your electrical system, the specific requirements of your local codes, and the potential for future expansion. A 4-wire system offers greater flexibility and is generally considered a safer option, particularly in new installations or when upgrading an existing system. It's also important to understand the concept of grounding versus bonding. Grounding refers to connecting electrical components to the earth, providing a path for fault currents to flow. Bonding involves connecting non-current carrying metal parts together to create a low impedance path for fault currents. Both grounding and bonding are essential for electrical safety. Now let's discuss some common misconceptions about grounding. One misconception is that a ground rod alone is sufficient for providing adequate grounding protection. While a ground rod is an important component, it's only one part of the overall grounding system. The equipment grounding conductor, the bonding of metal parts, and the proper sizing of conductors are all equally important. Another misconception is that grounding is only necessary for safety. While safety is a primary concern, grounding also plays a role in reducing electrical noise and improving the performance of electronic equipment. Proper grounding can help to minimize interference and ensure reliable operation. It's also important to note that electrical codes are constantly evolving. What was acceptable in the past may not be compliant with current standards. Therefore, it's crucial to stay up to date on the latest codes and regulations and to consult with a qualified electrician whenever you have questions or concerns. When working with electricity, safety should always be your top priority. Always energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. We remember electricity can be dangerous and it's not worth taking unnecessary risks. Let's also consider the potential impact of ground loops. A ground loop occurs when there are multiple paths to ground, creating a circulating current. This can result in noise, interference, and even equipment damage. To prevent ground loops, it's important to ensure that there is only one path to ground. This is typically achieved by bonding all metal parts together and using a single point ground. Now, let's discuss the importance of regular maintenance of your grounding system. Over time, connections can corrode, ground rods can become damaged, and conductors can deteriorate. Regular inspections can help to identify potential problems before they become serious. It's also a good idea to test your grounding system periodically to ensure that it's functioning properly. This can be done using a ground resistance meter, which measures the resistance of the ground path. A low resistance indicates a good ground, while a high resistance indicates a problem. In addition to ground rods, other types of grounding electrodes can be used, such as ground plates and underground metallic water pipes. However, the use of these electrodes may be subject to local codes and regulations. It's also important to understand the difference between a grounded conductor and an equipment grounding conductor. A grounded conductor, such as the neutral, is intentionally connected to ground to provide a return path for current. An equipment grounding conductor, on the other hand, is used to connect non-current carrying metal parts to ground for safety purposes. These two types of conductors should never be connected together except at the service entrance or separately derived system. When installing a ground rod, it's important to choose a location that is free from obstructions and that has good soil conductivity. Avoid areas that are rocky, sandy, or dry, as these may not provide a good ground. It's also a good idea to moisten the soil around the ground rod to improve conductivity. In some cases, it may be necessary to use multiple ground rods connected in parallel to achieve the desired grounding resistance. The spacing between ground rods should be at least equal to the length of the rods. When connecting conductors to ground rods or other grounding electrodes, it's important to use appropriate connectors that are listed for grounding purposes. These connectors are designed to provide a secure and corrosion-resistant connection. It's also important to follow the manufacturer's instructions when installing these connectors. Let's also discuss the requirements for grounding portable generators. Portable generators typically have a grounding terminal that should be connected to a ground rod or other suitable grounding electrode. This helps to protect against electric shock in the event of a fault. It's also important to follow the manufacturer's instructions for grounding the generator. In addition to grounding, surge protection is another important aspect of electrical safety. Surge protectors help to protect electronic equipment from voltage spikes caused by lightning or other electrical disturbances. Surge protectors should be installed at the service entrance and at individual outlets to provide comprehensive protection. When choosing a surge protector, it's important to select one that is rated for the voltage and amperage of your electrical system. It's also a good idea to choose a surge protector that has a high surge current capacity. Finally, remember that electrical safety is an ongoing process. It's not something that you can set and forget. Regular inspections, maintenance, and upgrades are essential to ensure that your electrical system is safe and reliable. By following these guidelines and consulting with a qualified electrician, you can help to protect yourself, your family, and your property from the hazards of electricity. Remember to always prioritize safety when working with electricity, and never hesitate to seek professional help when needed. So to reiterate, the 4-wire system is often the most highly recommended because firstly, it provides the best isolation of ground fault current paths, reducing the likelihood of unwanted current flowing through the neutral conductor. Secondly, it strictly adheres to modern electrical codes, which generally prefer or require separate neutral and ground conductors downstream from the main service panel. Thirdly, it minimizes the risk of neutral currents causing voltage drops or interference with sensitive electronic equipment. And the 3-wire system might be considered if firstly, local codes permit it, though this is becoming increasingly rare. Secondly, the installation is in a detached building or structure where specific exceptions may apply. Thirdly, cost savings are a significant factor, but it's crucial to weigh this against the potential safety and performance drawbacks. Remember to consult NEC Table 250.122 for sizing equipment grounding conductors for grounding fault current protection. It is crucial to remember that bonding connects non-current carrying metal parts together to create a low impedance path for fault current return. Grounding is the act of connecting the electrical system to the earth. Both serve different yet equally vital roles in electrical safety. Ensure proper separation of neutral and ground is maintained throughout the system to avoid creating parallel paths for neutral current. This prevents issues like voltage drops and electromagnetic interference. Consult with local electrical inspectors or a qualified electrician. It can provide guidance specific to local requirements and ensure compliance with all applicable codes and standards. Before making any changes to your electrical system, it's always advisable to get a professional opinion. Consider using a ground resistance tester to verify the effectiveness of the grounding system, ensuring it meets code requirements. This will confirm the path to earth. The general recommendation favors the 4-wire configuration because it offers a higher degree of safety, improved performance, and better compliance with current electrical codes. The 3-wire configuration might be acceptable in limited situations, but always ensure it meets local regulations and prioritize safety. Ensure all connections are properly torqued and protected from corrosion. Poor connections can compromise the effectiveness of the grounding system. If the panel feeds sensitive electronic equipment, the 4-wire system is especially recommended to minimize interference and ensure stable operation. Finally, remember that electrical codes are subject to change. Always refer to the latest version of the NEC and local amendments for the most up-to-date requirements. So, while both options are possible, firstly, the 4-wire circuit with a separate ground rod is generally recommended for its superior grounding protection and compliance with current electrical codes. Secondly, always consult local electrical codes and regulations before making a decision and have the installation inspected by a qualified electrician. Thirdly, if the panel is located indoors, the equipment grounding conductor should be run through a grounded conduit. Always prioritize safety and compliance when working with electrical systems.